Good morning everyone. Welcome to this video, which is the part 4 of the series titled Beginner's ROS Tutorial using ROS Development Studio. The purpose is to go through the basic concepts of ROS and at the same time explore the capabilities of ROS Development Studio, which is an online cloud facility that lets you experiment with ROS and run ROS programs on the browser, that means on a cloud instance itself. So in our previous videos we saw various concepts like ROS, nodes, topics, how to create package, how to set up your workspace and things like that. And particularly in the last video we saw how to create messages and service files. Alright, and in this video we will see how to create our own publisher and subscriber node. So you can do it using C++ as well as Python. In this particular video we will just focus on Python. So we will go here. A publisher is a program, or it's a node that publishes data on a topic, and subscriber is a program that subscribe to this topic and receives the information. Alright, and by writing such publisher and subscriber node we can implement our own algorithm. Okay, so let's start it. So what we will do is we will go to our ROS Development Studio. This is the starting window here, and we'll start our shell. Okay, so cd catkin workspace, cd src, hopefully ROS cd beginners tutorial is there. We go here and we'll create a folder called mkdir scripts, cd scripts, and here we'll download a file called talker listener package here. So let's see, copy and paste here. So it downloads a file called talker.py at this location. So let's give the executable permission to this file, chmod a+x talker.py. So it turns green, that means it's an executable one. And what does it contain is this. It imports ROSPy and string from the standard messages. We define a function called talker. So we create a publisher by this command, rospy dot publisher, and we give a name called charter. It takes a message of type string and queue size is 10. Then we rospy init node starts this node called talker. We'll see this, all these things are explained here. So this we have seen. So basically what it does, that rospy.publisher doesn't create a node, rather it just declares that your node is publishing to the charter topic using the message type string. Okay, and the init node is important. It tells ROSPy the name of the node until ROSPy has this information, it cannot start communicating with ROS master. Okay, so we'll see what is there. Okay, so I think Docker is the topic name. We'll check it. All right, and then it declares the rate of publishing this message, so which is 10 hertz. All right, and so it publishes a string called hello world and the time onto this publisher called pub, which is declared above. So we publish this string and we'll make a log of this string as well. That means let's see what is the role of rospy.log info. So it says rospy.log info performs triple duty. The messages get printed to the screen, it gets written to node's log file, and it gets written to ROS out. ROS out is a handy tool for debugging. You can pull up messages using RQT console instead of having to find the console window with a node's output. We haven't covered RQT console, which we'll leave out for the time being, and maybe it is required at some later stage. So but we understand that log info, what it does, it just logs out. It's more like it, what do you say, you keep a record of what all is getting printed, what all is getting published and things like that. So it just not only prints the data to the screen, it also write it to the log file as well as the ROS out. Okay, so more or less we understand. All right, and in the main function I think we just call the talker, and it is not available, then it interrupts it calls exception to stop the program. So let's see. So maybe we can see the content using the IDE itself. So if you go to Catkin workspace, SRC beginners tutorial, and then you have scripts, and then you have talker.py. Okay, so this program we have downloaded just now, and as we can see it has the same content. Let us see what happens. Does it run here? No, it does, I think. Okay, for the time being, let's see what happens. Anyway, we'll also create the subscriber node, and then probably we'll analyze both of them. So let's do that. We'll go to the same console, and we'll also download the listener one. One we had the talker, another is a listener. So we do the same thing, a plus x listener.py, and we can see the listener file is already there. So again, what we have here, we have a callback function. We'll see what it does. All right, so it just logs the information that is passed on to it. For example, data is the information which is passed to this function, and that gets recorded along with its caller ID. Okay, and there is a listener function. It creates a node called listener. All right, probably it is the subscriber, and it subscribed to the chatter topic. Let's see, and process that data whatever we get by using this function called callback. and ROS spin is a way to continue in a loop. Okay, and in the main program what we do is the call the listener. Let us understand it little bit better. So in it that declares that the node subscriber to the chatter topic, which is of type, this one is this. So it's just a ROS subscriber to subscribe to this topic. The flag, the anonymous equal to true flag, tells ROSPy to generate unique name for the for the node, so that you can have multiple listener.py nodes run easily. Means if there is a name conflict is there, it creates a new node. So ROSPy.spin simply keeps your node from exiting the node until shutdown. It's okay. So everything is done. We just run catkin make just to make sure that nothing is broken. So catkin make, yeah, everything looks here now. So let us see what these two nodes do. So what we do, in the first one we run ROS core, then we start another shell, we go to cd catkin workspace source double setup.bash and then ROS run beginners tutorial, let's say talker.py. So what you can see that it publishes hello world with a timestamp. Let us start another shell. Now if we do cd catkin workspace source table setup.bash, now if we do ROS topic list, so you can see that chatter is a topic that is available, and if we want to see ROS topic type chatter, you see it publishes data of this type, standard message string. Alright, and if I want to see ROS topic echo chatter, what it is publishing, if you want to see, you see you see the data is hello world and this time. So we know now what this is, and if you want to get more information you can just write ROS topic info chatter. So it says this is a node, okay, it has a timestamp, and it's a publisher, it's not a subscriber, and it takes a message of type this. Okay, so we have the complete information. Maybe we can revisit the code once again to see. So we understand the talker is the name of the node. So you can see, sorry, we'll put it here. So this is the talker is the name of the node, and the anonymous true says that every time let's say one node is already existing, it will create another node with a new ID, so that there will not be any naming conflict. So that's what it does. Let's do that. Why can't we do that? we start another one and we say cd catkin workspace source devel setup.bash. Now what we do, we see ROS run beginners tutorial talker.py. we start another node and it is also publishing some data. And if I see now ROS topic list, you still have only one topic, alright. And if we see ROS topic info charter, you see both the topics, the talker 5080 and talker 5924, both are publishing to the same topic called charter. So the topic doesn't get replicated. However, there are two timestamps, two IDs, two nodes are there with same name but different IDs. So that is the meaning of anonymous equal to true. If we make it anonymous equal to false, probably the new node will override the previous node. So I don't know, I haven't checked it, I'm assuming it, but at least we understand that what does the anonymous equal to true flag does. It creates a new node and both of these node publish to the topic chatter. Okay, so we'll stop it, and that's how it resolves the confusion if there are multiple nodes. Now if I run the same thing, so now you see there is only one publisher. Okay, fine. In the okay, now we'll do ROS run beginners tutorial, and we now run the listener.py. it is our subscriber node. So what it is saying, so this is the node name and it is say heard hello world, this one, that means it's listening from the other node. So let's see the file once again. Okay, so this is the talker part of it. We saw that it creates a topic called chatter and initiates a node called talker. Anonymous is true and it publishes the data at a rate of 10 Hz and the string is published called hello world and the time. Okay, that's all it does. Now listener 1 gets the caller ID of the probably the node and says I heard and the data that it hears. So the listener does what? It creates a new node with a name called listener, and again the anonymous is true. That means it's the node name with some timestamp or something. And so if you create multiple nodes, then it will create a different name for the node that starts with listener. And this function also subscribe to the charter topic. Okay, and it collects the data using the string type messages. Okay, and process the data using callback. So one thing to note is that the callback function parameter is not mentioned here. So that means it understands that the data which is of string type is automatically passed to the callback function. Okay, and then you run the listener. So this is quite automatic, isn't it? It doesn't tell what data to process, and somehow it knows that the data is of string type. Quite surprising to me. So whatever data you collect from the subscriber, that is automatically passed to the callback function. Okay, and in the main function we just call the listener one. Okay, so if we go now let us start another terminal, and if I do it now, ROS topic list, we still have topic chatter. There is no new topic is created. Okay, that is one thing to note. And if I do ROS topic info, if I want to get more info about this, now you see the there is one talker and one subscriber. That means one publisher and one subscriber, and both of them subscribe to topic chatter. That means talker is publishing data to chatter and subscriber is subscribing, that means listening to this information. Okay, and if I have to see, let us say RQT graph, just to show the relationship, we'll start the GUI. Start again. So what I see here, so it is quite straightforward, isn't it? We have a talker node that publishes to chatter, and we have a listener node that subscribes to chatter. So this talker and listener are the programs that a user can write to process the information or publish the information. This is how we write a publisher and subscriber. We'll see one example when we discuss about mobile robot and things like that. There we will create our own algorithm using this publisher and subscriber nodes. In fact, you can have only one program where you both publish as well as subscribe. You don't need to have two separate programs. Okay, so we close this, we close all of them. Let us see if we have covered all the things. So you have seen this. Okay, so we just stop everything. Okay, here ROS score is there. We stop this one as well. Okay, all right. Now what we'll do is that we'll create a service and a client in Python. As we recall, the nodes can communicate in two ways. One way, you create topic, so and then you create a publisher command. You publish the data to the topic, and then another program called subscriber can subscribe to this topic. That is how the information gets exchanged between two nodes. So publisher node publishes the data, subscriber node subscribe to the data, and this thing is you can say that asynchronous, in the sense that the data is flowing, anybody can subscribe to it. There is no control over who should access the information and who shouldn't. And the another mode of communication is through services. That means you make a request, and and this server, after doing a handshaking, it provides you a response. That means you can control who would access the information and who won't, and you can build that information. So the information will be exchanged only after the handshake happens. So we'll see how we can do that. All right, so again we go back to our original folder. Let's go to the editor here, and I think we have already done this step where we create this service files, right? So just to check that we have all the files in place, we see cd src, cd beginners tutorial, and you have the srv, cd srv, and you have this add 2ints.srv file is already there. If you see the content, if I do cat add 2ints.srv, it just says that what input it will take. It will take two values of type int64 and gives out the sum. Okay, so that's all it does. So what we'll do now, so we'll go to our script folder, cd script, and probably we'll make use of that, and add a new file, and we call it add 2int server. So we'll say add 2ints server.py. okay, and we'll just copy the content to save time, then we'll understand what it does. Okay, so let us see, and we give it the executable permission. So if we see ls chmod a plus x add 2ints server.py, you can see now it has become green. That means it's executable. So let us understand a little bit about this program. Yeah, before that probably we should make some changes to the sigma elixir file. Make sure that Python script gets installed properly, uses the right Python interpreter. So if we see ls gvim, we'll just make use of the editor. Here we have CMake list, and we'll search for catkin install python, control F, catkin install python. So we'll uncomment this part and program scripts. You say add 2ints server.py, and destination is not important. We will just comment it. Okay, so what we do is that we add the scripts add to int server.py in catkin install python. Okay, so this makes sure that the servers we wrote is accessible to catkin make. So what basically it does, the only thing it does is that it creates a add to int server and calls this service add to ints, which takes a service message of this type, and then handle to it ends calls this function handle to it to add two ints. Basically what it does is that sums the two inputs a and b and returns a plus b. Okay, and this is the add two ints is the response that it sends. Okay, okay, so I think a beginner tutorial.srv is the folder, an srv within beginner tutorial. It calls two function add two ints and add two ints response, and note that we have not created this add two ints response file inside the script. I think it happens automatically, so we have only created this add two ints .srv file, and I think it creates this on its own. Okay, and finally we just call this add to int server. Okay, so so what it does that it creates the service add to ints. Okay, with the add to int service type. Okay, all requests are passed on to the handle add to ints function, and handle add to ints is called with instance add to ints request and returns instances of add to ints response. Okay, and then ROS spin is simply keeps the code from exiting until the service is shut down. Okay, so now let's write the another script called client node. So what we do, go to the script, new file, add to ints client.py, and then toggle the light, this one, copy the content, copy, Control V, Control S, then we'll give the executable permission to cd scripts, chmod a plus x add to ints client.py, and as you can see all of them are green. That means all of them are executable. So what we'll do is that we'll add this file to this section catkin install python within cmake.list. So we come here and now we say scripts add to ints client.py. Okay, and now so what it says that for client you don't have to call init node, so you client, let's see, so you don't have any init node command in the client. Okay, ROS by wait for service, this just waits for a service to be up. Okay, it does nothing until the service is available. All right, and then because we can handle just normal function, we just call this service proxy add to ints, which takes a message type of this type, and it generates two objects. One is add to ints request and add to ints response. Okay, if it fails, then it calls an exception. So that is a standard thing. So what it does is that once this is called, it waits for the service to be available. If it is not available, it says service called failed. If it is available, what it does, that it calls this service. That means it makes a request of this type of service request it makes, which is add to ints, and passes these the variable whatever is there to this function and gets the response. That means internally it calls this function. All right. Okay. Okay, so if you see the main one, it is when it is called, the parameters are directly passed to the command line itself. We'll see how it does that. So if you don't give the parameters, it will give you the error called print usage and say that look, you call the service or program along with the parameters x and y. If you don't, it will give you an error. And once you have done that, it says print requesting this, and then prints the sum of these two things. So the add to ints client is called in the main function. Add to ints client is called, and add to ints client does what? It waits for the service to be available. If it is available, then sends the data x and y and gets the response, which is printed. So I think it is pretty much clear how it works. It's a template, so you can modify each component of it to make your own program. Alright, so we'll first do cd catkin this, catkin make, there is some error with catkin install python. Let us see what is that error. Maybe I need to put them in the same line. Scripts add to ints underscore client dot py. I hope there is no spelling mistake. So if I go back here, cd here, and I run catkin make, called without a destination folder. Okay, all right. So if I go back to CMake list, so maybe we just have to keep this line destination, and then let's go back, run catkin make, Yeah, so everything is fine now. So okay, so now we'll examine how do this service and client work. Now in one terminal we'll run ROS run beginner tutorials, add to in server.py, ROS cd beginners tutorials, srv folder is there. Add to ins.srv, add to ins I hope that I hope that I have performed these steps just to make sure package.xml, in package.xml if I see build depend message generation, exe depend message runtime, cmec list find package catkin, ROS cpp ROS page run message generation, and add service file, control F, add service file, add to ins.srv. So this looks okay. If we have done that, yes, ROS run beginner tutorial, add to ins server .py, beginner tutorial .srv. This it is not able to find this one. And what if we run this, the other one, the ROS run okay, so we'll pause for a moment. Is we'll have to do source devel setup dot bash. Okay, now if I run, let's say, ROS run beginners tutorial and add two ints server.py, unable to register with master node. Okay, so we'll have to run the master node as well. That means we'll run ROS core. So the moment I say ROS core, it's saying ready to add two ints. That means our server is up and running. In another folder, we'll do same source table setup.bash. Oh, I mean another terminal, not folder. And now ROS run beginners tutorial, add two ints clients. Okay, if I run it, it gives a error saying that I should pass two arguments. So I run it again, and this time I give 10 and 11. So see, you see requesting 10 plus 11 and the output is 21, and it is saying, the server is saying returning 10 plus 1 equal to 21. So this is how the handshake happens. Alright, so the error happened earlier because I didn't update the ROS tree, so it was not able to find the SRV folder within beginners tutorial, so it didn't have any clue where that folder is. So once you do this, and then everything works fine. So as you can see, server keeps running, so it waits for a request to arrive, and once request arrives, then it processes that information and returns the value, and the client makes the request. And if we are to see what kind of topic available, servers are not shown here, but they will be available if I see ROS service list. See, if you see ROS service list, you have this add two ints as a service, and it has its own logger. Alright, this is there. And if we ROS service -h, we want to see more help. I want to see more info on this ROS service info, add two ints. So it says that it's a node, which is service node, and it requires a message type of, or whatever service type, add two ints. And if you want to see what is add two ints, and it requires two arguments a, b, so it gives a lot of information. It says that this is the server, it is of type add two int service, and it requires two arguments a and b. If I want to see ROS service beginners tutorial beginner, let's see, beginner tutorials, add two ints. The tabs are not working. Oh, sorry, the reason it was not working is that I had to use ROS service show. So if I do this, then it says, it takes two inputs and gives out the sum. So so now if I type srv beginner show beginners tutorial, add two ints, so it gives me all this one. And if I want to see srv info and beginners tutorial, it doesn't do. Add two ints, ROS SRV info, it doesn't do it. Maybe let's see, tab doesn't work. Add two ints, if I do it, it gives the same information. There is nothing more to that. So that's how we see ROS service we use to see information about the service that is available. And there is something called ROS service args, print service argument. So if I see ROS service args add two ints, it says it takes two arguments. You can know what kind of input it requires. All right. And ROS service type, if I see ROS service type add two ints, so it is of this type. So in ROS service list provides all this information, okay, or ROS service info provides all the information together. Alright, so we see that how the ROS service works. So here you can build a lot of authentication and other formalities within these services. That means once a user makes a request, you can verify if it is the right user or not, and then give him access or serve him. So alright, so we have finished this part. We saw how this service and the client is working. Alright, this one. So to summarize today's session, we saw how to create our own publisher and subscriber node using Python. They allow asynchronous exchange of information between them. And then we saw how to create a server and a client program that will make handshake with each other before a request is served. So we'll stop here today, and thank you for attending this session. Goodbye.